So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a quick topic test with a collection of some GCSE exam style questions on scatter graphs at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now before we get started, it's worth mentioning that scatter diagrams or scatter graphs can appear on both calculator and non-calculator papers, so there's no specific need to use a calculator on these questions, so it could easily appear on both papers. So let's have a look at question 1. So question 1 says that the scatter graph shows the length and width of some leaves. One of the leaves has a length of 34 millimeters right down the width. Now one thing I noticed from this scatter diagram, this is probably just due to copying, is that the labels of the axes are missing. So let's just label this as length and let's label this vertical axis as the width. So what we need to do is find the length of 34, which is along the bottom, and you can see it's going to be this x here. So then if we scroll across to find out the value, we can see that the width of that leaf is going to be 24 millimeters. Then for the second one, it says all the points except one show strong positive correlation. Circle the point that on the graph that does not fit the pattern. So you can see that it is showing positive correlations because it's all going up. So if we were to draw a line of best fit, it would look like that. Which one looks kind of off? Now this one is really particularly difficult. You would expect one to be a little bit more rogue, but I would go on a whim and say it's more likely going to be this one here. So that is my answer for B. Moving on to question 2, it says the time spent cycling and running on 10 days are shown on the scatter graph. And it says the average time spent by cycling per day is 175. The average time spent running is on the 10 days is 160. Plot the point 175, 160 on the graph. So here we're doing 175, which is here, and 160. Which is going to be, well, looking at the squares going up, each square is going to represent 5, so it's going to be here. And that is my point for A. Let me just mark that. Now, what you don't want to do is mark it with a huge circle, just either an X or a little dot, but it's one that's definitely noticeable would be absolutely fine. The next one then says draw a line of best fit for this data. Now, for this, because we're given the averages, so this is the mean of the x-axis, this is the mean of the y-axis, then you need to make sure that your line of best fit goes through that point you've plotted into A. Now typically you wouldn't have to do your line of best fit going through a specific point, but if you're working out the average of x and y, your line of best fit has to go through that point. So looking at this now, when you draw your line to what is acceptable is that it's got to go through the two boundaries that I've marked here. So your line of best fit has got to go through these two little ports and this port here. So as long as you're and preferably through this point. So make sure that your line of best fit goes through this point. So when I draw my line of best fit, and let's just quickly do that. And again, you always want to make sure that you're using a sharp pencil and a ruler, of course. So I would say that should be absolutely fine. And I would say that's my line of best fit. So again, the two criteria is that it's got to go within the two markers, the two ranges that I've spotted, and preferably through the point that you have drawn. It then says on another day he spends 150 minutes running. Use the line of best fit to estimate the time he spent cycling. So for this, what you need to do now, everyone's answer is going to be different based on where your line of best fit is. But what you need to do is at 150 for cycling. Let me just double check it is cycling. It spends 150 minutes running. So I'm definitely, that's one mistake I've already made. So here, if I get rid of that, and let's go for a different color. So we go for 150 here. And you're projecting horizontally until you hit the line of best fit, and it's this value that you then want to read, whichever is off on your graph. Now an acceptable answer is any answer between 165 rather. So any answer between 165 to 225, but make sure that you are reading off whatever you have plotted and try and draw these lines so you can see in evidence that you have used your line of best fit. So I would say mine is probably around about, I would say 190 going forward. So I'd say 190, which does fall within that range that I've done. It then says, on another day, he did no running and no cycling. What assumptions can you make about the effects this data would have on the result for part C? Now for this, I would say it's going to have no effect at all. So you could say none, as it may be a rest day. Or you could say something along the lines of it would 0, 0 would be an outlier. So ignored when drawing your line of best fit and then reading a value off it. So it's not going to have any effect at all, but you need to state your reason. Moving on to question 3, it says the scatter graph shows information about the results of 10 students in 2 tests. And the first question says, use the data has strong positive correlation. Describe in words the relationship between the results in the first and second test. So for this, what you want to say is something along the lines of the higher, I don't know why they always give you a small space to do this, but the higher the mark in the first test, the higher the mark in the second. So here you do not want to talk about correlation because it's already mentioned correlation. Here you want to talk about the actual relationship. So here you could even go the opposite. So you could say the lower the mark in the first test, the lower the mark in second. And you could say that, I wouldn't say go along and say the similar results because they might not be. Basically, it's just an increase in one equals an increase in the other. It then says for B, it says in her first test, Hannah got 38%. Use the estimate her result in the second exam. So for this, we want to find 38 here, which is the one box before 40. And then with that, you then want to project across to this number here. And I make that out to be about 26. Then for question 4, it's just a case of matching up the graphs. Now again, just try and ignore the misalignment of each of these. So this one shows, the middle one shows a weak positive correlation, and the last one shows no or little correlation. It then says here are 3 scatter diagrams, scatter graphs. Which graph has the strongest correlation? So it's not the strongest positive or the strongest negative. It's a case of which graph, the points in which graph are the points closest to the line, and that's going to be graph B. Then it says which line of best fit should not have been drawn, and that's going to be graph A, as it shows no correlation. You shouldn't ever draw a line of best fit if there is no correlation. You only draw a line of best fit if there is decent correlation, whether it be negative or positive. Moving on to question 6, it says that Adam wants to use an archery game at a school fair. He asks people to shoot arrows at a target from different distances. He obtains the following results. And the question says he wants to make 60% profit on what he charges players. Use line of best fit to work out how far the distance should be. So for this, if he wants to make 60% profit, then he wants that equals 40% in the people losing. Winning, sorry. Not losing. It's going to be 40% of people. Oh, I'm spelling it wrong. Winning, because obviously 60% profit equals 60% of people's losses. And if this is the probability of hitting the target, that then means that you want a target of 40%. Let me just do that line already. And from this, what I then need to do is draw a line of best fit. Now again, I've already marked in blue the little ranges of where your line of best fit needs to go through. Let me just use a different color. Let's go for green. And let me just try and draw my line of best fit so that it does go through each of those targets. And let me just put that there. And again, it's never, everyone's sort of going to be different. I would probably say something along those lines would be absolutely fine. So from this, I can see that my target is going to be roughly around about the range of, I would say, potentially 24. So looking at here, let me just move that a little bit across and move that there. So yeah, so again, it's going to be dependent on your answer, but I would say probably say it's going to be around about 24. But you need to make sure that you are, one, drawing your line of best fit. You'll get 1 mark for marking 0.4, and then whatever the boundary is for there. Let's say about there. So moving on to question 7, it says Sarah cycles home from work each day. The scatter graph shows information about her journey times, and it says Sarah leaves work at 5:12. Use the line of best fit to estimate the length of her journey home. So for this, what we need to do first is draw our line of best fit. Now again, everyone's line of best fit is going to be slightly different, but as long as it's going within that range of the 2 blue markers, as you can see, then that's going to be absolutely fine. So let me just try and perfect that. I'll say, yep, that looks decent. So then at 5:12, we need to find 5:12. So each little box represents 1 minute. And you then want to draw a line going up till it hits the line of best fit, and then go across like so. And then you want to read off whatever time this is. And I make that time to be around about 5:44 p.m. Now the question doesn't ask what time she goes home. It says to estimate the length of her journey home. So then what I then want to do is then look at the time difference between 5:12 p.m. to whatever time you've got p.m. and I make that out to be around about 32 minutes. So then my answer is 32 minutes. Then moving on to B, it says that one day she works late and does not leave work until 6 p.m. Write down 2 reasons why the scatter graph might not be useful to estimate what time she comes back. So again, one of the reasons is, well, you could say that 6 p.m. So 6 p.m. is outside the range of the scatter diagram, or the data collected. Because you can only use the line of best fit between the ranges of the smallest value and the biggest value, the 2 extreme points on the left and right of your scatter diagram. Anything outside of that is not going to be accurate. And another one you could have given is that if she's going to leave work at 6 p.m, that the traffic / road conditions will have changed. And you could mention like rush hour, and something along those lines would be absolutely fine for the 2 marks.